everybody. Welcome to another vBrownbag. This particular brown bag is the story of two clouds, 8 data centers, and a 1.5 exabyte object store. And I'd like to introduce Matt Welch from EMC. He'll be giving the presentation. This deployment was done on Mirantis OpenStack. My name is Ben Silverman. I'm from Mirantis, and I'll be here to answer any questions at the end. Matt,
thank you.
Give it to you.
Can you hear me? It's great. All right, so my name's Matt Welch. I'm from EMC Cloud Services. We work on the public-facing cloud for some of our bigger enterprise customers. I want to talk to you a little bit about a new venture we did for one of our big object storage clouds using Mirantis OpenStack to manage the management infrastructure of our environment. There we go. So a little bit about us. We are EMC. We run kind of a hidden object storage for some of our big customers. Right now it's at 1.5 exabytes in 8 data centers across the world. We're expanding that right now, continually growing it. We're a remote team, so we're all over the world distributed for our entire org. And just another sales pitch, we are hiring. So if anyone's interested, talk to one of us in the front. So kind of a background history is we ran a VMware ESX environment for some of our previous builds. It was a very static enterprise-like cloud. It was somewhat painful to build new things in there. We were turning up new environments pretty much quarterly, which made it very difficult to expand and keep up with the demands our customers were needing. So when we went to a new version or a new rebuild of a greenfield deployment this year, we had the opportunity to look at OpenStack or any tools that we needed. The problem was we had 90 days. We had a short period to deploy this in. So we had to get up off the ground running really quickly and get something that we could test in the lab and into production. The second problem was we had to deal with internal and external workloads. So we had our internal needs to manage the object storage service, but then we also had external customers that would be on that to support and get compute workload close to the cloud. So we had to handle that, and the second piece was we needed high bandwidth. We were talking hundreds of gigs per second input, that we needed a platform to manage that and keep it going without any downtime. We had a lot of time where we had to move stuff around, but we couldn't have a complete outage in one site. So to help us do that, we turned to Mirantis and the OpenStack 6.1 Juno release. We needed to get something up in the lab fairly quickly, so we used Fuel and the team at Mirantis to help us get that going, get it stood up. We were able to get that deployed in the lab within 30 days, kind of get some of the bugs worked out, get things testing. And once we did that, we needed to look at some of the networking pieces. So we turned to OpenStack, Cisco and Mirantis to work together to use the Cisco ASR Level 3 Neutron plugin, which allowed us to isolate provider networks from our tenant networks that would be on the cloud consuming it. That allowed us to get some of the high bandwidth that we were looking for in the front end, but also allows for a provider internal side network perspective. The other piece was we were doing 8 clouds in 90 days. It all had to be remotely automated for deployment. We had no one on site or anyone managing the cloud. From a physical perspective, we would all be in one war room for pretty much a week getting this deployed. The second piece we needed is once it was built, the ink's never dry on these things, so we had to manage some kind of way to manage the cloud on top of that. So we spent quite a bit of time working with SaltStack and some salt formulas to manage the deployment afterwards, to keep some of the changes that we needed to do during the live production deployment up to date. So one of the things that we noticed when going through this process that a lot of people thought OpenStack was a nice thing to have. It was a requirement, wasn't a need, but as a internal team, we knew that we needed something better than the old static enterprise environment. So we started in the lab using a little bit, and there was a few people in there that asked for logins or credentials to use the cloud. We found out quickly that lab became production pretty much within a week. We had no opportunity to continue testing on that. We had to stand up a new lab, which made it somewhat difficult there. The other thing we noticed is we were doing CI/CD deployments of our entire stack from the object storage perspective on top of our OpenStack cloud. So we were able to tie in some of our automated deployment pipelines to do a full stack deployment, run testing against it, tie it in with some of the traffic impairment tools that we were using to generate, the front-end traffic that we would see on top of our OpenStack cloud. Having OpenStack there allowed us to quickly turn these up, turn them down, and scale that out to a point where we knew what we would expect in production. One of the things that we've noticed afterwards is that the production deployment that we finished up about a week ago now has been overwhelmingly successful. We're at to the point now where we're already ordering new hardware and expanding our cloud out for the end of the year. And some of the other things that we're looking at is we need to meter in planning for some of that growth. So as more and more people have come up and gone on the cloud, we have no way of knowing who's using what or what's actually there for permanent usage. So we went through, we need to go look at metering and planning. The other item we're looking at is SRIOV. So we have some of the high traffic workloads that are coming in. Some of it is network inspection detection that we're looking to do. The problem is that needs to be at 10, 40, and almost 100 gigs per second at some of the peak times. So we're looking at using SRIOV to pass some of that through. The other option we're looking at is Cassandra and SSDs. So we're working on a large Cassandra deployment to handle some of the metadata stuff in the cloud. Problem is at 1.5 exabytes, that Cassandra instance becomes very large. So we're looking at trying to utilize some of the SSDs and some of the compute nodes to scale those Cassandra instances out and make it widely available through our footprint. The other thing we want to continue doing is looking at our CI/CD jobs. Once we found that we can turn the entire stack up on OpenStack, do full testing of the entire stack, we no longer were guessing when we were doing deployments. So now that we can do full testing and automation in the lab, we want to try and develop that further to do more OpenStack testing, more OpenStack deployment testing on the cloud, and continue some of our full stack testing. That's it. So if there's any questions or anything. Yes, sir.
It's probably a silly question, but what was the object store that had 200 petabytes per instance, cloud instance that running?
200?
You had 1.5 exabytes.
Yes.
Per 8, so I'm assuming around 200 petabytes per. That's pretty big.
Yes.
So I'm curious what that software was.
That software is using a piece of EMC code and some of the internal written that we've done. So some of it is ECS and Atmos code. So we run. But all that is managed through some of our automation that's now running on OpenStack. Perfect. Thank you.